Welcome to another episode of the Mapscaping podcast. My name is Daniel, and this is a podcast for the geospatial community. This year, 2025, I was fortunate enough to attend the FOSS4G event in Auckland. It was fantastic. I met some brilliant people there, and I even managed to record a few podcast episodes with them. And this is one of them. I really hope you enjoy it. Hi, Lynn. Welcome to the podcast.
Hi. How are you?
Good, thanks. So just for context, for the people listening to this, I've just pulled Lynn out of FOSS4G here in Auckland. So if she's sounding like she's a little bit surprised, she is. She wasn't expecting to do this today. But Lynn, you're the Director of Data and Technology at HOT OSM.
Yes, that's correct. I am part of the technology team. I'm leading the team at HOT, and HOT is a humanitarian OpenStreetMap team that is focused on improving livelihoods through open map data. That's in a nutshell what we do, and we build open source tech to enable that.
And it's some of that open source tech that I'm really keen to talk more about today. But give us a little bit more background. Like maybe you could describe a project that you've worked on before, just so the listeners have an understanding of what HOT does.
HOT aims to engage community members in creating map data and using map data for their own challenges. So basically, when people have challenges related to flooding, related to wildfire, related to disasters, related to waste mapping, we engage communities and we work together with communities to map areas, whether that's building or waste or trees or whatever, with them to engage them in the process of the mapping and the map data use, so that when they are part of the process of generating map data, they can also be part of the process of doing something with that map data. So it's all about including citizens in generating data so that they co-own the whole process.
So I completely understand that. You're giving them agency in the project, helping them understand it. I think too, if you're involved in it, you understand it more deeply, more willing to trust that the results that come out of that. What about accuracy? Would it be more accurate to do this from space?
So accuracy is not the most important element. Like, it depends what you want to do with the map data. Sometimes if there's a disaster, you just want to know which buildings are destroyed and which ones are not. You don't necessarily need to be super accurate. So accuracy of the data depends on the use case of the data. Now, satellite imagery, drone imagery, aerial imagery, we use that heavily, and we'll come to that, I assume. But it's only like one that doesn't include any local knowledge. It's just what you can extract from sensor data. As soon as you want to know, like, do elderly people live there? What type of doctors are available in this hospital, especially in the countries where we are working? That's not something you can extract from sensors. So the whole imagery space is critical for mapping, but you really need to engage also the local communities to add local context to that imagery and to extract the right data that's needed for their challenges. And they know best what is important.
It makes a lot of sense. And I had an idea what the answer to that question might be, but I just needed to ask it anyway, just to, again, so the listeners have a little bit more context. We mentioned this really, really briefly at the start. You build technology as well. Just before I dragged you away from the conference, brought you in here, you were describing a technology that you were building with predictive modeling. But could you start with drones, please? And then we'll sort of walk our way up to this predictive modeling.
Yes. So mapping in general, most of the time starts with imagery. You need some real-world reference of the world to start mapping. You can use camera imagery for that. You can use drone imagery. You can use satellite imagery. You can use aerial imagery. But you need some type of real-world reference to map, because the whole idea of mapping is to make a reflection of a real-world data, real-world situation. HOT typically works in low and middle-income countries. That's our focus areas. We work with vulnerable communities to put them on the map with them. Because when there's disaster strikes or before disaster strikes, the data is available for health workers, for community workers, etc., to act upon in an emergency, for example. Now, going back to the imagery, one of the key gaps or the key problems in our space is that there's no recent high-resolution imagery accessible and available in many of the areas where we work. For example, if we want to do a project in, let's say, Ghana, Accra, and we want to have the latest up-to-date high-resolution imagery, very often that is not available. Or it's available at a very high price at like the Maxars and the Airbuses, etc. So what we are doing, we do receive satellite imagery from Maxar, Open Data Program, post-disaster. But that only works post-disaster. So it's like Jamaica disaster recently, we received imagery, but that was only because there was a disaster. Very often we want to anticipate, or we want to be able to work pre-disasters. We want to work on development projects, which are not necessarily disaster related, And that's where we do need imagery. And that is today a gap. Today, Bing still delivers us some imagery, but that's also like not the right resolution very often for some of the use cases. So what we looked into is how can we, in a community-led way, generate imagery that we can use for mapping. And drone technology is becoming a commodity. It's like the prices of drones are dropping. The drone technology is becoming more and more accessible. So we are, since a few years, investing a lot in drone technology where low cost, low weight drones can be used for mapping purposes. And so what HOT is doing, we're experimenting, building actually a hardware drone ourselves using like 3D printers. Like it's a very experimental project where we're trying to build a very low cost hardware drones. That's one topic, which we can easily deploy in the countries where we work. We are building drone technology that mainly enables our community members to very easily fly drones with high resolution over a larger area. Because one of the challenges of a drone is that you can't capture that same area as a satellite on a short amount of time. But if you would fly several drones at the same time, so you basically generate multiple flight plans and people can fly in parallel on different areas, and then you stitch them all together, you actually have high resolution imagery over a large area. And we just were able to finalize this for the first time on like 80 square kilometer in Freetown, which is like really large area for drone tech. And all that imagery is being processed using Open Drone technology. So we ourselves are building Open Drone Tasking Manager, which basically tasks drone pilots to know which flight plan is going to be flown by which pilot. That all gets processed by Web ODM, so Open Drone Map. We're closely collaborating with ODM as a partner. And then that all gets pushed to Open Area Map, which is a platform where anyone can share open imagery and download open imagery. So if you search for certain imagery in Freetown, you go to openareamap.org and you will see that imagery. And this is the same like in many areas of the world. So by enabling communities themselves to fly drones with low-cost drones, like $500-$600 drones, you basically enable communities themselves to be in the driving seat of the image that they want to capture for their own projects. We're not dependent on satellite imagery or anything else.
That sounds amazing. So we're setting up a tasking system. Please go out and collect data over this area. We're interested in that. You do that, you do that, you do that, and we'll stitch it together. How does that work? Like my guess is like different people using different drone technologies, different resolutions, different cameras, maybe different formats that it's coming out, and perhaps different levels of accuracy in terms of, where is the position of this thing on the ground?
That's a very good question. Right now, our drone tasking manager works with 5 models. Mainly DJI Mini 4 Pro, Mini 5 Pro. We need like the very simple, let's say the low-cost models. We also work with like Mavic, so it's possible to also today use 5 different type of models. What is currently high priority on our roadmap is to integrate many more models that are out there, because indeed of the realm of like models, and they're constantly coming out new models. So we want to make sure that we can cover as many as the most popular drone models out there, low-cost drone models. Now, there is the whole processing pipeline, and to process all that data is a nightmare. Like it is definitely a problem we are working on. We're definitely investing a lot of time and effort in that because, there's multiple challenges. One, indeed, the exact resolution of every drone can be different, but also like one drone can have an issue, returned home, where do you restart? There's a bird flying into a drone. Okay, that doesn't work. You have to do the whole quality control, and it's all big data. It's all big data processing. If something like it takes time. And so right now we are investing a lot. We have dedicated people working on improving that data processing pipeline, because it's not only like when you fly, they don't necessarily match exactly. Like, so there's an overlap, of course, that we allow because we're also experimenting with 3D imagery. So where you actually need overlap from drones. But it took us some time, but like we managed to prove that it's possible in Freetown, just like this is like last month. That's why I'm really taking this example. And we are going to replicate this in Dakar, in Dhaka, and in Malawi in the coming 6 to 8 months. So the fact we know it's possible makes us like,
That sounds awesome. And congratulations for making all that stuff work. It's pretty incredible. It makes a lot of sense to me to sort of, at least at the start, limit the types of drones people can use. I guess that sort of limits the number of problems you have to solve in terms of imagery anyway. If I'm a drone pilot, can you walk me through what that looks like? So do I have to create the tasking or the flight path myself when the drone comes back to me, assuming everything went fine? Am I then responsible for running a process on OpenStreetMap to process the data? Or could you just walk me through the process? What does it look like for a drone pilot that wants to contribute?
Okay. I'll let you know what is today the process and what will be the process in a year.
Perfect.
Because there's a really plan to make this much simpler. Today, the process is that typically you have a project coordinator, which is often someone from HOT, our own organization, that creates the project and that creates a flight plan. And then with the USB cable, it's still like very much non-optimized at the moment, uploads the flight plan on the drone. The drone flight basically pushes on the button. You typically always have somebody else who checks that the drone, is not doing anything wrong. You normally need to be with two people to like fly a drone. And then at the end of the flight plan, the drone comes home. And then normally, if that all went well, if there's not too much wind, if there's no birds, like if the whole situation, there's no rain, it's not a rainy season, like there's quite some parameters there, then that drone imagery gets uploaded on a local computer. Then from that, it still needs a PC. It's still not mobile only, but that's our plan. And from there, it's uploaded on our own servers. So we actually have on-premise servers at the moment where we store the imagery. That gets processed at the moment by HOT ourselves, together with collaboration with ODM. And then we push that imagery to OpenStreetMap. So today, HOT is still very much supporting the whole process. In a year from now, we aim to make the whole process mobile-based. So basically, a drone pilot does not need a computer because there's many challenges. You need a computer, you need the internet connection, and very often you don't have the connection the moment that you need it. So there's quite some challenges there. But what if in a year from now, if you have just a mobile phone and a drone, you push your flight plan that you receive from your project coordinator from your mobile on your drone, you do your drone flight, drone comes back, you upload that drone imagery on your phone, push on a button, and everything would happen in the background and it gets published on OpenStreetMap. So basically, a drone pilot would not have to process any imagery. He or she would just have to say, look, I want to create 3D point clouds, like depending what derivative you also want to create from that imagery. That all gets pushed to OEM. OEM is OpenStreetMap, and that's where anyone can see and view that image, because we really push for open data, open imagery. Then we stick to that. It's a core principle of open imagery.
It's I haven't seen it yet in real life, obviously, but it sounds incredible. And I can really see a future where that could add so much value. And some of that value I think it's going to add is the next part of the conversation around predictive mapping. So now that we understand that satellite imagery or imagery in general is really, really important, it adds a lot of context, but it doesn't give us features. It doesn't give us the outlines of features. And we need people for that still today. Can you walk me through how you're using predictive mapping to speed up the process of creating those features?
Yes. So today, indeed, there's a lot of manual mapping ongoing from satellite imagery or drone imagery, where people basically draw polygons, points, lines on an image. Today, we're optimizing this, amongst others, using a tool which is called MapSwipe, which basically is a pre-process where people indicate just by swiping left or right on an image, on a mobile, or even on a PC, is there an image or not? Just scrolling through a mobile app. And then the tiles where it was identified that there is an image by a human, and that gets checked by 3 humans, so there's a statistical approach to it. These gets uploaded to what we call Tasking Manager, and in Tasking Manager, people will actually draw over the building. So people don't have to search the whole area to find, is there actually a building in this area or not? This is just an example. That's today the process. We have a pre-processing step, and then people draw manually buildings through our Tasking Manager on OpenStreetMap, because again, we want to push as much as possible data in OSM. What we're working on right now, and that we also have a proven result from that, is that we want to use open AI models. Open AI models mean that it's open code, open license, open training data, everything about the model is open. We use open AI models that can extract objects from imagery to make the whole mapping process AI assisted. Why? Because then it's also faster, it's more efficient, especially post-disaster. You can do much more in a short amount of time, and you don't have to engage as many people. People will basically train models and validate models. Now, what happens is that when we use a generic open AI model, those are often trained in Western countries. So they have no clue how reality looks like, let's say in Papua New Guinea or in Chad, areas that are very, very different. So what we do is that we use open source models, and we generate localized models from that. And how does that happen? When you use a general model that's trained on generic data, we're going to fine-tune the model with specific training data, so specific, let's say, outlines from buildings in Chad or outlines from buildings in Papua New Guinea, and train that model with that data. Based on that, you generate a localized model which works for that area, meaning you can reuse that same model to remap the same area for that area. The human is actually in a loop at every step. The human is in loop at creating an open localized model from that generic model. The human is in the loop by generating training data to optimize the results of the model. And the human is in the loop at the end of the model to validate if the prediction that came out from that model is like good enough or not good enough for the use case. In the case of OSM, because ideally, again, we push all our data to OSM for the data that fits into OSM, there's two ways to do that. There's a way where you basically download all your predicted features from our tool, which is called FAIR, AI system mapping tool. You download all those features and you conflate them using JAWSM, one of the ideators, back to OSM. A project we're currently working on is to make that even more simple, where you don't need to have a PC and JAWSM, what have you. You can just use map swipe. Again, that same simple swiping. It's like a Tinder-alike application where you just swipe left or right. Is this building predicted feature, whether it's in this case, I'm just using the example buildings to stick to a simple example. Is this building good enough based on the imagery I see? If there's already an OSM feature, if there's already open data, which one is the best one? Is it the OSM one or is it the predicted one? If it's the predicted one, you can remove the OSM one and replace it with the better one. And that all happens, again, by humans that are verifying whether the AI predictions are good enough for the use case. In the case of OSM, the use case, it really needs to be very high quality. The buildings need to be square, like the level of correctness and completeness, etc. in OSM is very high. But for some use cases, that's not necessarily the case. In some cases, like post-disaster, if you know how many buildings are there, if they're exactly square or not, that doesn't really matter that much. So depending on the use case, and that data doesn't go into OSM, that goes into open data layers, which we then can push to Humanitarian Open Data Portal, HDX, or other open data layers that are used by organizations, around the world.
I'm glad you mentioned that. Like some data is maybe not the best for OSM. I was thinking about the high quality data. If we're looking at an area that's just been ravaged by fire, flood, wind, whatever, those buildings are going to change hopefully very, very soon and be rebuilt. But at the moment, they might just be, a mess on the ground. Can you tell me, please, or explain, please, the training process again? So my understanding was you gave a fantastic overview, but just so we can dive down in the training bit. So we have these open general models that we use, and then we train them. Is this a case of the user sitting down and tracing around buildings? This is a building, this is a building, this is a building, this is a building, and then pushing a train button based on my input?
How it works is that a project manager, typically, because all our work is typically done in a project environment, project manager selects, I want to map this area. He or she selects imagery to do that, and he or she selects a general model to do that. From that general model, to be able to create a localized model for that area, indeed, people will or draw still the polygons, or in this case for buildings, polygons, to generate training data for that area. For example, if it's round huts in Chad, people will actually draw the circles, and that will be used as a mask to basically compare the imagery, your real-world reference, with your masks from your training data.
And this is the project manager that's doing this. Is this correct?
Yes. So the actual creation of the localized model, that's the project manager, but the actual generating of the training data, that anyone can do that. So anyone can train a local model. Just like anyone can now edit OSM, anyone can generate training data for these localized models. So that's why there's like really two profiles in this whole picture. There's typically the person that needs some technical knowledge to kind of, generate the models, etc., to see if the parameters, if the accuracy, the typical parameters of like intersection of a union and all these like more AI related metrics are being verified. But then you have the actual people that train models. That could be anyone. And especially when we will be using map swipe, so this tool where you just swipe left and right, anyone, in theory, even my grandmother, she could just swipe left. Yes, this is a building. No, this doesn't look right. This looks good. So you only would need a mobile to be able to validate models. Right now, we're not completely there yet. We're still on the step of where you need an actual laptop to draw those training data. But the next step is to use a mobile phone and validate and train models using mobile phones.
It's an incredible world we live in, hey, where this is even a possibility. It's amazing.
It drastically lowers the barrier for anyone to be included in an open source, open mindset. Because why are we all doing this? There is indeed a lot of like Google and Microsoft, and they all have these models. Some of them are open, some not. But we really want to create a world where citizens themselves are in charge of their own future, where we're not fully dependent on a few big tech, and tech that is not open. There's no way to collaborate on that tech. For example, RapID is currently one of the tools we also use, that also AI assist mapping, but the whole AI piece of it is a black box. We only get the predicted features. We can't give any feedback to the model. We can't train a model. We can't create localized models. So people are not in charge themselves of the maps that are being created. And very often, map data is a reflection of real world reality. And it is a power game as well. If you're on the map or not, and who is on the map and what is on the map has a massive impact on the real world actions.
Yeah, I totally agree. I think a lot of people have had mapping done to them in the past, and now it's their turn to decide, like, well, actually, my world likes this. I am doing the mapping. I think a really important step. We talked earlier about oftentimes that the satellite imagery that you get from some of these big satellite providers is after, post-disaster, and you want to be able to collect imagery before a disaster or, for another project. Would this also be true for this predictive modeling that we're talking about, for extracting features from that? I'm just thinking of the example before where you talked about 80 square kilometers. If there's no disaster happening there now, would you then also start tasking people to go in and create these models, localized models, and start extracting features from that area?
Absolutely. So today, HOT is working on disaster-related topics like pre, post, recovery, etc. Also development-related topics. Can be waste mapping, can be flood mapping, like anything which is not necessarily disaster-related, can be health projects, can be rooftop farming. Like it's really broad what we're working on. Today, when there is a disaster, we get imagery post and pre-disaster. So we know which buildings were there and which are still there, often from Maxar. So we do have that imagery in the case of a disaster. Now, HOT exactly wants to be able to map their areas also when there's no disaster involved. And that's where the drone imagery comes in. If we don't have imagery, we basically can generate our own drone imagery. We can create our own localized AI models, and we can create all that data irrespective of a disaster or not. Like this, there's so many use cases where you need map data, which is like not necessarily disaster related. So yes, we are also creating localized models in projects which are completely not disaster related, because it's all about making mapping more efficient, lowering the barrier to mapping for anyone. Right now, a person still needs a PC to map a building. You don't map a building on a phone. That wouldn't work. So if you really want to include everybody, you have to go mobile, at least in the areas where we work. And that's where if you enable anyone to train and validate models on the mobile, you can do it anytime, whether that's disaster related or not. Most of the projects we're actually now doing are not disaster related. We're having projects that are related to disability access in cities. We have projects related to what are the risk assessments for dengue or malaria in some countries. We have projects related to detecting fish ponds to enable communities to optimize the ponds where they will or not do aquaculture. We have projects related to waste, as I mentioned, in East Africa, we did recently a lot with youth mappers where people are mapping waste. Then we have projects related a lot to flooding as well, because many of the vulnerable areas in this world, like many informal settlements, which are basically slums, but we call them informal settlements, are often based in very vulnerable areas. In the countries where we work, for example, if there's mangrove deterioration that has an impact on the flooding in that area. So what we do is that, for example, in those projects, we map mangroves. We map what is the change in the mangrove vegetation. So the realm of what HOT is working on, we are the enabler, we are the catalyzer. We don't decide what we map. If a community says, hey, I really would like to map this for this use case, or we work often with organizations that, for example, they are community health workers that need to support people for medications or vaccinations. They need map data to know, okay, where are the kids based? How do I optimize all my community health workers? And that they also need map data. They need to know which people are living where. And again, we're trying to support those organizations without us making a call what should be mapped, because they know best what is important locally.
Yeah, I've got a few more questions about this, but before we get there, does that mean, you just said HOT is the enabler? Does that mean I could start up a project tomorrow? I can go in and say, hey, look, I'd like to map this, that, and the other thing, and then use your infrastructure to make it happen. And of course, the data that comes out the other side is open.
Absolutely. That's the whole intent. We really don't want to be... HOT is a 75-person NGO. It's not huge. The whole idea is that we don't do the work, we enable the work. And that anyone can create a project. You can tomorrow create a project using hot technology, using any other open source technology. We basically try to fill the gaps in if that's not available out there. So the whole idea is that anyone can actually create open map data. And for us, what is critical for us is that it is open, that everything we do is in the open. That's where that's one of our key principles.
Up until now, we've been using buildings as an example. Is there a reason why we couldn't do this with other features? And to be perfectly clear, I understand why buildings are important. I see that they're often used for a proxy for population. But is there a technical reason why we couldn't do features, rivers, trees, other structures, roads?
100%, we are going there. We're actually right now, we set up the whole system for buildings because that was the first use case. We're now looking into rooftop building material because that's also very important for disaster. Like if there's an earthquake, depending on your rooftop or your building material, that has an impact on infrastructure and people. We're looking into like detection of trees. We got requests on detection of seagrass. You get all these requests like, hey, can you map this with AI? And then, so the next step for our open AI assisted mapping tool is that we don't integrate the models ourselves in our tool, but we make it a platform for geo AI models that can plug into the model. So basically, with the new stack MLM standards, which are very recent, you can basically create, let's say, an input-output model where people can plug in their model. They basically plug in their open AI model. For example, Heidelberg University is working on waste detection AI model or on surface type of roads. They plug in their model. We make that accessible to the portal for the open mapping community. If you're a project manager and you want to map the road surface in an area, you go to our open assisted mapping tool. You choose, I want to use the model for mapping a road surface. I'm going to localize that with the training data that I'm generating. I'm going to create a localized model, and I can run this whenever I can validate the prediction of the model. So that's why we're moving away from ourselves being the AI implementer to being the platform where GeoAI models can be plugged in. There's quite some like Hugging Face. There's all these platforms that are out there, but they're not made for the end user. They're made for developers. They're made for like people that know exactly what they're doing in that are technologists. Basically, we are trying again to lower that barrier. If I want to map, let's say I want to map rooftop farming, I would need a model. Like I would go to our OpenAI assisted mapping tool, search for the model that fits my use case, generate my training data, and then use those predictions to map.
Does that mean then that somebody would be curating those models, or I could go to Hugging Face, find something I liked, and say, "Hey, this is the one for me," and plug it into your system?
Yes. We're now talking to several universities that are actually developing these open source models to see which ones are the first ones we can actually plug in, and then make those accessible for the open mapping community. And again, we're lowering the barrier for the mapper. We're lowering the barrier for a project manager. He or she doesn't need to be the AI engineer. The person can just select a model based on, what actually needs to be mapped. And from there, it's like a very easy workflow to the actual mapping. The fact that today we focused on buildings, because we also learned a lot out of the models we currently have implemented ourselves, is that it takes a long time to implement it, that some models are being maintained, others are not being maintained, and the world is changing so quickly, specifically when it comes to AI models. There's no way we can keep up to date. Like, why don't we open the whole platform? Anyone can. And then in the long run, the whole idea is that Hult will probably like propose models. Like if we get a request from a project mapping fish ponds, we might say, look, we suggest you to use this model because we know it works well. In the very long run, the idea is that the community themselves can up like models and say, hey, this model worked well for me in this area. Oh, actually, I want to map something similar in my area that looks similar to yours. Let me reuse your model. And so, again, this is like a longer term, but the whole idea is that then anyone can map using open source models.
I don't know what to say. This sounds awesome.
I think it is awesome. We have a great team to do all this.
It sounds amazing. It'll be so interesting to see what projects come out of this, what's possible. Well, obviously there's a little ways to go before we get there, but when we're there, like exactly what that will enable, that'll be fascinating to see. That'll be absolutely fascinating. How does this all sort of jive with OpenStreetMap? Is there any tension there?
There's a bit of a tension, yes, in the sense that OpenStreetMap does not allow AI-assisted mapping. The whole core of OSM is that it's a community-driven project. People map. we fully align with that. Like this, again, we're the humanitarian OpenStreetMap team. We try to get as much as possible data into OSM because that's also where everybody can reuse this in the most easiest way. However, because this is an AI-assisted mapping approach, there is some tension with the open mapping community. People say, why does it need to go faster? Why don't we just do it fully human? So there's many just comments by principle, but there's also a comment like, hey, the AI is not necessarily better. That's definitely true today. But the fact that we include the human in the whole loop, it is actually a human process. It is people train their models, people validate the models, people push the models to OSM. So we are trying to advocate for this process, especially in the countries where we work, because very often the pushback comes from OSM communities in the Western Hemisphere. And if you ask many people that are working with us in the lower and middle income countries, they actually want to have the data in. That's more important than having it exactly squared or having it. So there is a tension anyhow between in the whole OSM ecosystem, but there's an additional tension with anything that's AI assisted.
Yeah, I was listening to you talk before, and you were very careful to say there's a human loop here, here, and here. And I couldn't help but wonder if there was a little bit of tension there when you're talking about publishing it back to OSM. My guess is, though, whether it makes it into OSM or not, this is incredibly valuable data to be downloaded to their own environment and worked on and analyzed there, no matter what.
Absolutely. OSM is our preferred platform, but not all the data fits there. That's one. And two, if it's not possible to kind of get it into OSM, there's open data layers that we could publish on multiple platforms. And we are publishing that, like especially on HDX, they're an open data platform from the UN OCHA, where most of like the multinational organizations go to download the data from a country whenever there's like a challenge. That data also gets pushed by HOT on those platforms. So ideally we do it in OSM, but not necessarily.
This is a silly, it's going to sound like a funny question. Do you enjoy your job?
I love it. Yeah.
It's so yes, clear when you're talking to you. For the listeners at home, I'm sitting across the table and this woman is incredibly enthusiastic and it's awesome. Thank you very much for doing this work. Really appreciate it. I wouldn't know how you begin to set a price tag on what you're doing and what this will become in the future, but it's going to be significant and it's going to be incredibly valuable to a lot of people. Thank you for your time talking to me today, and thank you very much for your work.
Thanks a lot, Daniel, for giving this opportunity to talk about it.